Alright guys, welcome to 6.4. Today we are talking about nth roots. So let's get right into it. The nth roots. An nth root is basically just an inverse of raising a number to the nth power. Okay, so we just used n. N could be any number. But say we have something like a to the n is equal to b. If that is the case, we know that a is an nth root of b. Okay, so if I were to look at this and I took the nth root of b, that would be equal to a. And that's what we're doing here. We're taking the nth root of a number. Okay, so it says because negative 3 to the fourth is equal to 81, negative 3 is a fourth root of 81, and 3 is a principal root. Okay, so we're going to get into how to do all this shortly. First of all, let's look at some symbols. The symbol with an n on the outside like that just means nth root. That indicates the nth root. Okay. Not too many people use this term index, but I guess it's good to know that's called the index, that nth root, the n piece. Obviously, this is a radical sign, and then inside the radical sign we have the radicand. Okay, so just some terminology here before we get into it. Principal roots. Some numbers have more than one real nth root. For example, 64 has two square roots, 8 and negative 8, since 8 squared and negative 8 squared both equal 64. So when there is more than one real root and n is even, the non-negative root is called the principal root. Okay, so notice that 64 has two possibilities. We always go with the positive one as the principal root. So that's all principal root means. Sorry, one more thing here before we get into some examples. Real nth roots. Okay, so suppose n is an integer greater than 1 and a is a real number. If a is greater than 0 and n is even, okay, so when we're looking at even nth roots, there's one unique positive, one unique negative real root, right? So whenever it's even, we have the possibility of like negative 2 squared and 2 squared both equaling 4. So there's two possibilities there. If n is odd, then there's only one unique positive and no negative real roots. Okay, so there's only one unique root. So if I have an odd power, like negative 2 to the third, that is equal to negative 8 and negative 8 only. Okay, there's no other possibility there. So whenever this is odd, we have one possibility. If a is less than 0, then and n is even, then we know that there are zero real roots. Okay, if a is less than 0 and n is odd, then we know that there is 0 positive and 1 negative real root. Okay, so this is talking about if we have something inside of here, and this is odd. So if I had, and this is negative, I should say. So if I had negative 2 inside of there, that's an imaginary number, right? But if I took the nth root or the third root of negative 8, I get one negative real root, and that negative real root is negative 2. Okay, so I'm just undoing squaring, or like I shouldn't say squaring. I'm undoing powers, essentially. Okay, what happens if a is equal to 0? So what happens if I have a 0 in here? If there's 0 in there, then I'm always going to get 0 out, no matter what the even or odd power of that thing is. Okay, important note, I can have a negative real root if the exponent is odd. Think, negative 2 to the third. This is equal to negative 2 times negative 2 times negative 2, which is negative 8. Right, so we're just thinking about things a little bit backwards from what we have before. So example 1, they want us to, let me read the directions here to make sure. It just says to find the roots of this thing. Okay, so there's no power out here, so I'm just taking the square root of what's inside, right? So I will be left with plus or minus. If I take the square root of 36, that's 6, right? And if I take the square root of x to the 10th, I get x to the 5th. So I get plus or minus x to the 6x to the 5th. And technically, if you go from an even to an odd exponent on the outside, I don't know that your book did this, but I think you're supposed to put this into absolute values. So that's kind of interesting. They messed that up. But be mindful of that. Whenever you go to even, from even to odd in your answer, and you take it out of radical form, we have to consider that that thing only was positive. Okay, so we have to take the absolute value of that. 1b, we have the negative on the outside. We're taking the square root of y plus 7 to the 16th power. If I do that, I'm left with y plus 7 to the 8th power. Taking the square root of something is just cutting it in half. Cutting the exponent in half would make that 8. Okay, so this is the final answer for that one. Odd powers, when you find an even root of an even power, and the result is an odd power, which is what we just did here. We took an even root of an even power and we got an odd power, then you must use absolute value of the result to ensure the answer is non-negative. Okay, so let's do some of these. Example 2 here, we have square root of 36y to the 6th. This simplifies to 6y to the 3rd, and since we went from even to odd, we must use absolute value signs. And we're done with that one. Here we're taking the 4th root. Okay, so think what number to the 4th power gives me 16. The only one I would even consider trying there would be 2. So, and sure enough, 2 to the 4th power is 16, so I have 2. And then here, so I've already taken that 4th root, and then here I'm going to divide that 12 by 4 to get 3. So you're always just dividing whatever this power is. So I have 2 times x minus 3, all to the 3rd power. Okay, and you're done with that one. So remember that 4th roots just undo 4th powers, right? So you can think of x minus 3 being written to the 4th power 3 times, right? Okay, so that 4th power just gets taken away, and you're left with 3 of those things. So I don't know if that made more sense or made it more confusing, but essentially you're whenever you take a root, you're just dividing this exponent by that root, and that's what's left. Okay, so 12 divided by 4 is 3. That's how I got the 3 there. By the way, since this now is in odd power, I need to have absolute values. So just be mindful of that as well. Whenever there's an exponent that is odd, we went from even to odd, and we had a variable in there that we have to consider that that thing is only positive. So we have to make that absolute value. Example 3 says approximate radicals. So it says the surface area of a sphere. I'm not going to go through all of this right now, but essentially they want you to be able to type this into a calculator, right? So you would just type that into a calculator, and that's all you have to do for this one. So I'm not going to go take the time to do that here. I'm going to actually just let you do your homework. Okay, so the big takeaways from today is this, you guys. Whenever you have let me go down here. Whenever I have something like this, where I have like a 3rd power, or what doesn't matter what I'm doing, like a 3rd root of, I don't know, what would it be, 27 x to the 6th or something like this. I know that 3 to the 3rd power, right, is equal to 27. So when I undo 27, you can think about that as I could rewrite this thing as the 3rd root of 3 to the 3rd power x squared to the 3rd power. Whenever you have the 3rd root, it cancels these 3rd powers out. Okay, so when I would simplify this, I would just be left with 3x squared. All right, so if that helps you, that's the last thing I'll say here, is if it helps you to write this in terms of whatever this power is, and then you just cancel those things when you take the root, the nth root of it, feel free to do that as well. Okay, so the last piece here that I'll do, so we did this one. We had the 4th root of 16x minus 3 to the 12th power, right? So I can write this in terms of 4th powers, right? So I could say this is the same thing as the 4th root of 2 to the 4th, and then x minus 3 to the 3rd, all taken to the 4th. Okay, so when I take the fourth root of this, these powers of 4 go away, and I'm just left with 2 times x minus 3 to the third power. Remember to use absolute values when you go from even to odd. All right, guys, we will work a bunch of these in class if we need to. But yeah, that's it. Nth roots. We'll catch you guys in class.